Hello, everybody. Welcome back to another episode of the Flocode Podcast. We're back in the game. We have a new baby in the O'Reilly house. Things are busy. Today, it's my privilege to have Dr. Mohammed Z. Naser as our guest. He's an assistant professor at Clemson University and a leading expert in integrating advanced technologies in civil and structural engineering. He has a PhD in structural engineering from Michigan State University, and he's done a lot of research focused on the shear response of composite steel girders exposed to fire. He has authored several books, including Machine Learning for Civil and Environmental Engineers. That's actually where I first encountered his work. And he has a whole host of other books, including Leveraging AI in Engineering Management and Safety of Infrastructure, and some other publications. I'll link everything in the show notes below. So, Dr. Naser, thank you very much for joining us. It's a pleasure.
Thank you very much for the invitation and for the kind intro too. Naser is just fine. Mohammed Ziad tends to be like very large for everybody's time, so we go with Naser, and I'm very appreciative of your time. Thank you.
Cool. So, I guess to set the stage here, in terms of context and some of the stuff that I want to talk to you about, the pace of research and development in machine learning and AI is staggering right now. It feels like we're in some sort of a gold rush, and I'd like to dig into some of the most fundamental and practical applications of machine learning in our industry, and really just come up with some sort of like an overview of machine learning for people that want to know what the practical applications are of these tools. So I guess we'll just start there, and maybe first you can give me your perspective on the field of machine learning currently and how you see it fitting into the industry.
That's a very good question to start this up with. It's a
You
very
know,
tough one too.
you know what, Nazir? Actually, I always ask a different, very deep question first, so I forgot to ask that. My first question is always, what is your life philosophy in a nutshell?
Oh, okay. Uh, we're gonna have to think about this, but like I don't think I follow something. I tend to be very intuitive with my life, but I think when it comes to machine learning and civil, in general, I think I just hope to see like drastic changes within the industry that happen within at least my lifespan.
Yeah,
That would be the philosophy I'm trying to follow. I know we tend to be a little bit conservative, a little bit slow to adopt new things, but it seems that this might be, or this could be the very good time to start like having that exponential growth with our technologies, and maybe we can do like very great things more than we can do right now.
yeah, yeah. I agree. Okay, so back to my second question. Your
Mhm.
perspective on the state of ML and how you see it fitting in.
Perfect. So I think the easiest, I always start with the following. If we a very good indicator to see where we can go is if we look at like other parallel fields and see what they can do, like for instance medicine, computer science, electrical engineering. They've all been managing to leverage AI and ML like extensively and very, very quickly. And they can do rapid things for much more complex problems than the one we have in civil. And if we can like at least better what they can do, or at least use 10% or 20% of what they could do, then our domain will start to see that exponential rise we start this talk with. And I can see ML as a very good layer there, because if you think about our domain, we have a lot of data. Our designs, a big portion of it is routine. A massive portion of it is like methodology or a process that we structure like step 1, 2, 3, 4, equation 1, 2, 3, 4. And whenever you have like a lot of data, a routine process, a structured process, this is a very good recipe to use ML to make our life a little bit easier. And we're not really trying to say let's just let ML design buildings for us. No, we're just saying let it do like the routine stuff where we get to do like the more complex things or like the more fun stuff for our jobs.
Yeah, absolutely. Yeah, I couldn't agree more. I think, as I see it, the big bottleneck for me personally in my industry. I work in power and water. And as you say, we have a lot of data, but it is unorganized, difficult to manage, needs a lot of cleaning in order to prepare it for practical applications. And I think that's probably that's the first bottleneck I see, is like, let's standardize the collection of data so that it's more useful.
Perfect. I mean, it's not really just us that we are facing this hurdle. Like, even let's say if you think about the other fields too, like if you think about clinics or hospitals, they also have like massive data within like seconds and milliseconds. They collect everything, and they managed a way to, and they figured out a way to organize it. I mean, it doesn't have to be like standardized like an ASC standardized kind of a way, but
Yeah.
they have to manage to do that. And I think we can do something similar, at least if firms can do that, that'll be great. And in a way, we really have them. We have our data structured, but it's not like in a machine learning friendly kind of way structured. So there is some room to work there on one end, and on the other end, it's not like we have to start like from absolutely zero, scratch or ground zero. We have something. We just have to make it. I think the more we learn about ML or the expectations from ML, the process would happen to be a little bit much more natural than we think it would be.
Yeah. Interesting. So you have a quote in one of your books that says, is it enough to be an applier of machine learning, or do we need engineers to be creators of machine learning algorithms? I think that's a great question. And to me, I think, no, I don't think people need to know how to create these algorithms in order to use them effectively. Like, we don't know how to build apps on our phones, yet we're all perfectly capable using Google Maps. So, yeah, what are your thoughts on that? Like, how deep do you think people need to go down this rabbit hole? Because it's infinite.
That's a So this quote stems from like a personal experience. So whenever like you're in academia, you have to apply for grants for proposals, and whenever like I tend to apply a lot on machine learning. Usually the responses come back whether declined or like too optimistic, and a big portion of it is that we don't teach coding, or like for instance, we don't know how machine learning works. So while I was thinking about all these things, if you think about like something similar, if you think about finite element or like ETABS or SAP to the softwares, we don't really teach the students to dig into the matrices and figure out like how the software works. We teach them how to use it. And if we can carry like a similar process to machine learning, you're gonna have like two schools of thought. School one, well, it's not enough just to use machine learning. We have to also be able to create it. But in a way, we use other software that we don't create, like Abacus, Ansys, all these. So we just know how to use them. On the other hand, I think it's also important not just to learn how to use something. I think it's also important to learn like some principles. For instance, we know kind of how SAP works. We know the matrices and partial differential equations, but we don't particularly know how the exact software works. So I think having a little bit of fundamentals would always help to visualize like the big picture, the behind the scene things. And then the application side is where we spend. Engineering by default is an application of physics and math. So this is where we really come in. We're appliers by trade. However, like learning to do or learning why we can do things or how we can do things would make this application process much more easier and general than what it's supposed to be, I guess.
Yeah, that's well put. And I think a fundamental understanding of the different types of algorithms that are available to you, and then kind of, figuring out, does this square block go into this square hole, or, which tool is the correct tool for this problem. And, I'm not an expert by any means, but the usefulness that I have found in just the basic linear regression and multivariable linear regression tools in scikit-learn, like, there's these easy functions that are immediately usable to anybody that has a very basic understanding of Python, and you're up and running with really useful models quickly. And I think the people just overlook it and they write it off as it being it's too difficult to learn, it's too complicated. But I really think that that's not the case. What's your thoughts on this? You're a lot deeper in this than I am.
I agree 100%. I really think that a big portion of the barrier is we might be a little bit overthinking the learning process.
Yeah,
Plus, we don't like, for instance, in school or like in university, we teach statistics, we teach linear regression, we also teach those like in even like lower grades in high school and middle school. But all of a sudden you go to a university then and then you graduate, and once one graduates, it's gonna like very hard for them to go back and start to relearn stuff. And then you have this machine learning, which looks like a black box. We don't really know, understand. We haven't had much experience with it, so it tends to make it a little bit challenging. But for the most part, for many of our problems, we don't really have to invent new algorithms. We can just use whatever existing there. And as you mentioned, the interesting thing is the algorithm is already online. It's open access. You can literally copy the lines and put it into your thing. The only thing that you literally need is your data, like the civil engineering data, and like a machine that can process and run the analysis. So it's not like a big deal. It's just like somehow we just have to, just go for it and see where we can go from there. It's not that hard.
yeah,
I don't think so.
yeah, and to give people just a sense of what can you do with these things. Just a very simple example is one of the earlier experiments that I had used this for was we were getting concrete test results from a site down in California where it was extremely hot, and over the course of a few months we got the data was structured in the same way every time. So you start to build a model where you can predict concrete strength based on specific temperature and specific timelines of when the tests were taken. Once you feed in this data, suddenly now you've got a useful graph. And then every time I heard they were doing a test and I could see what the temperatures were or when it was taken, I could pretty closely approximate the relative strength of that concrete. And that probably took me like 45 minutes to set that up, and it ended up being an extremely useful model. And that's just a small goof off. That's not a real thing. It's not a real deliverable. It's just to help me do my work. So you brought up an interesting point there on statistical methods. So in the book, you also have a point that says machine learning makes minimal assumptions about the type and the quality of the data, but it looks for hidden patterns within data points and then becomes effective when you apply it to unstandardized data or data with highly nonlinear interactions. That's a very useful observation, I think. And that's what's missing from statistical methods.
So basically what we taught in school, for the most part, we learn like parametric methods, which, as you know, you have like linear regression, multilinear regression, which basically says you have an equation. You actually have the equation. You just have like to fit the parameter and find like those coefficients. And whenever you do that, effectively you're saying, and this is what, like for instance, what we're not taught is whatever phenomena you're trying to model. Let's say compressive strength of concrete. The physics of or the whole phenomena can be described within this equation. Now, in reality, this is like a very big assumption because we know our problem is much more complex than that. But however, to be able to use the process or to be able to use the statistical method or the linear regression, we have to follow the assumptions. And the assumption says you have this form, find the parameters that minimizes the error. And this by default means this is your phenomena, this is your physics, this is everything that you can do. It's described within this equation. In reality, it's not, because it's not just a linear equation. It's not just like fitting parameters. Sometimes if you have like good data quality or like good data sets, the parameters would fit in nicely into the equation. You have like an R square of 95%. We're all happy. But that still doesn't mean that this is the physics. It just means that this is how you describe the phenomena within this expression. Now, machine learning, on the other hand, it doesn't really have to follow this pattern because most of it comes from non-parametric methods, which means we don't really have to have the parameters that we actually need. We have minimal assumptions about the data, which, as you know, it could be something good or bad because a coin has two faces. And in a way, our problems in reality are much more complex, are much more nonlinear. non-linearity is not just between the data, it's between the parameters themselves as well. So to solve such a nonlinear problem, we really have to use like a nonlinear method to be able to figure it out easily. And this is where the switch becomes from fitting equations into finding patterns, I guess.
Yeah. And once any engineer hears nonlinear, then, their hands go over the ears and no, like stop.
Yes,
Before
100%. This is like the
reverse.
biggest self-defense mechanism we have.
Yeah.
Because we're not really taught about like nonlinear stuff heavily.
Yeah.
I mean, many of us have taken probably like a numerical course or something in school, but these courses perhaps like in third year or like second year, like many years ago, hidden between like many courses. So we don't tend to focus much of it. And the other thing is, James, as you know, like our building codes, like the equations and building codes, for the most part, they're not really made from nonlinear methods. They're really, like basic fitting and stuff, numerical analysis. So this is also makes us a little bit hesitant to go into that very dark side of the math that we haven't been to before.
Yeah. And, I've made this point before about, back in university, it's the only time you have the space and the time to dig into the theory and really chew on the theory and be like, what does this mean? Like, what is going on here fundamentally? But you don't have at least in my case, I didn't have the experience or the lens to look at this stuff and be like, why should I care about this? And it's only years later when you have some sort of a real world problem, they're like, wow, I wish I could remember any of that stuff. And then I got to re-dig it up all over again. So I'm sure there's some insightful quote out there about how you should listen to stuff when you're being shown it in university. But yeah, hindsight's 2020. So I want to ask you about the challenges in the industry. We kind of touched on it, but about collecting and preparing high quality data. Like construction projects, or every project is different. Every company is different. Every team is different. From a commercial perspective, if you were running your own concrete design firm, how would you go about, collecting information in a useful way? Like, what are your thoughts on that?
Yeah, that's a brilliant question. I've been thinking about this a lot, to be honest, at least maybe for the past year or so, because I've been talking a lot with industry people about like how can we use machine learning to do this or that. So if I had like, let's say, my own concrete fabrication, I don't know, place or factory that I would use. Well, first of all, I would like to collect any data I can have, or at least see what type of data I can collect first, and then prioritize. I would like to collect this one. This could not be collected. Could be garbage. Could be something else. Then I would use this data to whether, like, let's say, concrete strength would be something very easy to trace. I have all these concrete mixes. I have all these concrete parameters. I start to collect these, cast the concrete, test it after a few days, collect all this data. The more data I collect, the more information I have, and the more my model would be able to better fit or predict, future concretes, for instance. But what I would personally do, and I don't, maybe this somebody would hear this and hopefully they'll try to implement it, is that I always think of data as like oil. So this data, if you have it, this would be like the source to create models. So the more data you have, the more you can use it and maybe start to maybe like lease this data or like sell this data somehow. And then you have like other companies, other firms that using your data to do other things. And this could be like something like an annual subscription or like a monthly subscription. For instance, every year, if you subscribe to my, I don't know, fabrication firm or something, I guarantee you like 1 million data points that you could use, high quality, organized, clean, that you could use for your models and stuff. So this would be something very easy to do. And there is a lot of ways, a lot of, of course, like ethical stuff with data privacy, but like luckily for civil engineering, we don't have like a lot of things we have to worry about if we think about concrete or steel. but you could always like do other things to anonymize the data, make it like usable for certain things, or like hide certain things. So these would be some things I think it would be valuable, and I think the future will be there, because if you think about this now, like all these marketing things, or like let's say platforms or companies. I don't want to mention names. I don't know if we can mention names here, but like let's say if you go to website X, you want to buy. I mean, I can't even say X because now it's at Twitter. If you go to website ABC and try to buy something, well, the more you buy from that website, the more like it keeps like sending you emails. Well, do you need this anymore? Do you need like this now to accompany the first item you bought? And if they're doing this and it works, it will work very nicely for us. Another easy example would be streaming TV or streaming like websites. You keep what you watch a show, and the moment the show ends, they're gonna give you like three different choices, and they say based on this show that you saw, we recommend these three different shows.
Yeah.
And it's exactly the same process as us, except our data is not TV shows, it's not like series. It's just engineering stuff that we all love to do, and we will all love to do. Get used to it.
It's funny. It's funny you mentioned that. Like, if I ever use my YouTube account to play like some sort of a cartoon for my kid, I am bombarded with children's shows on my YouTube. Um, that's an interesting point. And there was a conference in Florida in April. I can't remember what it was called, but it was exploring AI applications in the construction sector, and it was basically a lot of executives at firms were saying we everybody recognizes the importance of AI. We're putting money into AI, but we're still not quite sure where to put it exactly. And everybody's nervous about being the canary in the coal mine. But they also want to be a first mover, but they don't want to create an internal tool that somehow becomes totally obsolete next week when OpenAI released the next version of ChatGPT, etc. But one of the topics that was discussed was how some of the larger engineering firms have been approached by big tech on acquisition of data. So exactly what you just said. And for now, they said, no, we're not sharing this, because they understand that holding that proprietary data has value, and probably more value as time goes by. And you have a big competitive edge if you have millions of data points on projects around the world. But I think as time goes by, it's going to be harder and harder to hold on to this data and to hoard it. So I don't know. What do you think about that? It's an interesting one.
Yeah, I was at the international conference probably 6 months ago, and there was like a big social media company there. And it was a construction conference, and a big social media company was there. And this social media company said that they used to subcontract all their construction stuff to construction firms. And then once they realized that like how much the construction industry was making and how much they could potentially they could use it for, they decided to have their own in-house construction firm. And now the department head of that construction department within that big social media company was doing a presentation on how much data they collected on concrete for building all the data storages warehouses for their servers. So in a way, although these tech companies are approaching construction, companies for data, I think that more and more it would be something like, okay, well, if they don't want to share their data, we'll just have our own construction stuff, and we'll collect our own construction thing, and we'll contain our own construction data. And then the problem becomes they won't have as much data as the actual construction firms have, but they would have data that's clean, that's much more organized, and it's all what they need is, as you know, like if you, for instance, if you have a relatively small data set that's clean, there are many ways that you can like expand it or like augment it. You can make it much, much larger within like simulation or like AI stuff. So it's very interesting to see where the construction would go. I mean, construction industry would go. But my worry is uh, machine learning, I think, is not really our own business. So it's very hard for us to see where it would go. But for the machine learning companies, that's their business. And I mean, here's the thing. See the stuff that we have access to now, like all the chat GPTs and stuff. Imagine what they have that we don't have access to, that they might be released like in the future. So because they have the edge of knowing what's going to happen next, it makes us always in need for them, although we have the data.
Yeah.
Now, unless we start, like, maybe we start to hire our own civil engineers with backgrounds in machine learning, or you know, it becomes a little bit hard. But I'm just worried that we might be like on the lower, or on the poorer side of the coin, because the only thing that we have is data, and I don't think that's going to be something that's going to last for a long time, because as you said, we can't just hold on to the data for forever.
Yeah. Yeah.
Yeah.
Yeah, it's interesting. It's an exciting, like, in the last 2 years, probably since the commercial release of ChatGPT, the AI has just exploded, and I see it now in emails going back and forth for projects. You can tell this is absolutely written with ChatGPT, and that's happening more and more now with, like, emails you get from the dentist or whatever. It's all, so much stuff is AI generated now, for better or for worse. So let's go to some of your own work and research, and let's talk about, can you share any case studies or projects that you've been involved with where machine learning has had a big impact?
Yeah, so when you started the intro, you mentioned like my background was in structural fair engineering, which is really is that's where, like, I did my PhD and stuff, and then like somehow I got into machine learning. And for structural fair, as you know, it's a very small research area. There isn't like many structural fair engineers out there. And if you look at building codes, usually the fire chapter is very small, and it would only contain something like, we'll use this chart or use this table to figure out the fire rating for a slab or for a wall. So there isn't really much physics, much thought about that. And I think that my intro to machine learning was the following. I was trying to figure out a way to come up with an equation for, or to predict fire resistance of RC columns. So if you have a reinforced concrete column, you're trying to find the fire rating. We have a few equations, but if you look at their accuracies, they tend to be like on the low side. So I was trying to see if I can like fit a better equation, and it was really hard. And then I get exposed to machine learning, and the first, I think, one or two models I created, the accuracy was something substantial, like 80 something percent, 90 something percent, which was massive for this case. And what got me thinking is, well, if I can now use machine learning to create a model that can give me fire protection, fire rating for reinforced concrete columns with ease and with high accuracy, better than building codes, then why don't I just use it? Because building
Yeah.
codes table would say use, I don't know, 5 inches, but the accuracy is very low. But my model says use this many inches. You have low cost and your accuracy is very high. And then
If
this
you
is
if
this is
Nazar, if you can tell a developer that you can save them 3 inches of concrete or 2 inches of concrete on every column face, then that's cash. That's a
exactly
big win.
exactly
That's a big win. Sorry, continue.
exactly. No, I mean, I 100% agree. I mean, so I approached a few people, a few concrete stuff firms with this, and they were all happy to see this, but the feedback I always got is it's not in the building code. I can't use it. Like this method is not in the, so I can't do anything about it, although it's there. And because of that, I think what I was thinking about is the following. I was thinking about if my machine learning model can predict this thickness for it or this rating with this much high accuracy. And the issue is, because I use a machine learning model, I can't use this information in my project because it's not in the building code. What if I do this? What if I learn how the machine learning think, or how the machine is able to predict this rating? And then I'm going to use this philosophy, or like, let's say, this process to predict fire ratings from now on. And then this way, I don't have to use machine learning. I don't have to bother with the code, or with the building code being not inclusive of machine learning. I'll create a new method. And then this method could be something like linear regression, or like just a easy method that I can pass by the building committee and they would sign on it and vote. So this is what, like, a very, I think, case study where you could use machine learning to help you come with something new. And then once you figure out there's something new, you don't really have to use it anymore. You
Right.
can just use this information, give it to a building committee. Hopefully they'll agree. But of course, it takes a long time for them to vote on things. But hopefully we'll be able to do that soon.
Yeah, that's a cool story, and it's interesting. So, if you were to use that in a real project and you are operating outside of the building code, if you are the PE that is willing to stamp that design, that shows that although you may be operating outside of the building code, you've used your professional judgment and experience to say this is suitable and safe. Is that true? Maybe that varies state to state, but I think there is a little bit of flexibility in professional engineering to allow for that, right? Because not everything fits directly into the building code.
100%, 100%. And also, plus building codes, they have like the performance based, leg where you could like have some leeway to do so. And once you do something, you can I think you can review it with a third party, so that you have to convince them plus the building official. It's always tricky with machine learning until now, because the third party don't, there is very small number of engineers who can understand machine learning. But it's I think the future is that, because you could now you do performance based with finite element, which was something almost very hard to do a few, maybe a decade ago, but now it's much easier. So machine learning will follow. And I think the time span should be shorter, just because of how things are much more rapidly, you know, advancing. So I think we will be able, hopefully we should be able to do something within the next few years, I guess. Yeah.
Okay. So you have a series of lectures based on the book, on your machine learning book for civil and environmental engineering. They're on your YouTube channel. I recommend everybody check those out. But you do a lot of research. Do you do lectures? Are you teaching students about machine learning at Clemson?
I do. I have a course on machine learning for civil and environmental engineers. I teach it every third semester.
Okay, cool. And so how many sessions do the students get?
So it's
How
a
many
full course.
lectures?
It's a full. It's 16 weeks of lectures, so it's about 32 sessions,
Wow,
and
that's awesome.
yeah, there'd be maybe 30 without the midterms and final. So 30 lectures, and basically we start with data, and we end up with we start with data sets, data statistics, different algorithms, case studies, explainable AI, advanced methods in AI, and then we have a project to do along the way, along those 16 weeks. I taught it for the first time, maybe a year and a half ago. So I'm due to teach it this spring one more time.
That's awesome. And our students, presumably some of them are trying to learn to code along the way, or do you have prerequisites for them? Like, I think it's a fantastic idea.
Yeah. So one of the challenges with this course is, so I'm not a big person on learning to code. I think learning to code is very, very important. But when you try to teach something, let's say in for senior students, let's say they're gonna graduate next semester, or this is the last year, I think it's a little bit hard for them to teach them how to code things within 16 weeks plus cover the other things. So I do have 2 weeks on coding, where we start to code very small problems using Python and R. But I spend a lot of weeks on using platforms that have machine learning embedded in them. So for instance, these platforms, you can go in, you could drag algorithm A, you can drag the data, and the algorithm would run. So you don't really have to code per se, because everything is already in a nice graphical interface where we can use it. And that would be something I noticed that it was much more interesting for them to use this platform versus coding by hand, just because of the barrier of learning.
Absolutely. And you, in one of those lectures, I don't know which one it is. I think it's the one on algorithms. You share this
Hmm.
website. I'll link it down
Yeah.
below in the notes, where it shows the visualizations of each of the main machine learning algorithms. And when you see it visually, it makes so much more sense just to develop an intuition as to what the hell is going on. And when you see
Hmm.
the visuals, you're like, oh yeah, that makes a lot of sense. So I'll share that. That's very cool.
Thank
So
you.
for the listeners out there, check out that series of lectures. It's really good on YouTube. Covers all of the core concepts of Naser's book. What else I got here in my notes here? So we talked a little bit about using machine learning over traditional methods, and some of the pushback that I've gotten is, I explain how I think these tools are useful, and then somebody will inevitably say, linear regression has been around for 2,000 years. This is nothing new. And then, I know that. And it's not that it's a new method or, totally innovative, but to have it in a clean, accessible, usable function in an open source package makes it so accessible and immediately usable. Like an abacus has been around, and I'm not talking about the software, I'm talking about the Greek tool for counting things. That's been around for a while too, and there's not that many engineers using that. So I feel like there's a barrier here to pushing these tools. How do you think we cross that barrier, or can we push through it?
Yeah, I think with because we're like our background is like engineering and STEM, we by default a lot of us tend to be a little bit introverts, a little bit more on the conservative side. So we like the things that we're very familiar with, and whenever like there is something a little bit different, we try to not to push back, but like there is a defense mechanism that kicks in. Like, why do I have to do this when I have been taught to do A, B, and C, which is very understandable. So I think more and more this would be I think this would be minimized a lot, because the more I think about it is a lot of the new students in engineering now, the next generation, they were born and like they get used to all the tablets at a very young age. Like at our age, we just like internets and cell phones were like the biggest thing. But for them, I mean, like I can see like for instance, my nieces and stuff, they're like very very young, and they fluently use like all different types of tablets and software and stuff. So these kids, when they grow up, they're gonna be much more like they have that intuitive connection to software and AI, and it would be a lot more easier for them to link to machine learning, if not expected, because you can't just cut them off when they go to school and you say, well, now you can't use your tablet, we're going to be using linear regression, because they're expecting to, something familiar to them, like they're expecting to see the tablets, the software, the visual stuff. So I think this, let's say the next maybe, or 5 years ago, 10 years, 10 years from now, this 15, 20 years period would be a little bit critical, because this is the transition phase. This is where older engineers meet new engineers, and this is where AI is also rising. So I'm expecting to see this a lot, but I think it would start to cool down like once the new generation come up and rising. Plus, like with new generation, those people will like in 10, 15 years, they're going to be like project managers and like admins in companies. So they're going to also push for their agenda. And it most likely would have machine learning. I think what OpenAI did by releasing ChatGPT is that it just made everybody see how easy it is to use AI if you don't have to code. Like if you
Yeah.
have a packaged thing that you can leverage AI, and we can do the same thing. Every company of our own firms, they can have our own version of ChatGPT where you can like do machine learning stuff without having to hassle with coding. And you can always have like a small department, maybe 5, 6 engineers that are proficient with machine learning. They have a very good background in civil engineering. They can create these things for the greater use of the company. So it's there.
Yeah, that's a great point. Yeah, there's a lot of interesting stuff to unpack there. There's always been friction between each generation as they, move through. And it was the same for the senior engineers of today who are, in their 50s and 60s. They would likely have experienced the same friction back when, Microsoft Excel first dawned, and people are like, "Are you crazy? You're going to put it into this cell? You can't even see what's going on." And it is crazy. You can't see anything. You can't see
100%.
any of those calculations. But that's where I started with, was Excel, and probably you too, and VBA, and trying to write macros and, put going insane trying to figure out where the problem is, and you can't find it. So that was one of the joys of switching to Python, is that you can see everything and it's a lot easier to debug. So let's say you're a practicing engineer in the industry. You're out of school 3, 4, 5, 10, 20 years. Where do you start? If they want to get started with machine learning, what would your recommendations be?
I have a very good answer for this, because I think my example would be something a lot of people will relate to. So my background, so I graduated my undergrad with a very low GPA. My GPA was 2.67. So it wasn't fancy. It was 2.67 out of 4. I was like at the very low bottom of my patch. And it was hard to find jobs, to find everything else. But what I realized is linking your self-worth to a number, let's say a GPA or like a stat or something, it's not going to be something that would, at least in my case, it's not something that's going to be positive, because that number will always stick with you and it's going to be very hard to change that. So what you could do is just do it. Just figure out a way, say, okay, well, I have this 2,500 algorithms. Just pick one, like just alphabetically, just pick one and start reading about this. You have like Python and R, and then one of the most common questions I usually get is, should I start with Python or should I start with R? And I always say alphabetically B comes before R, so just start with Python and see if you're gonna like it or not.
Yeah.
It's not really hard. You just have to pick something. Now I understand, like, and this also comes back to our background, because like for engineering students, engineers and stuff, like we don't really like to have a lot of vagueness. We like to see, okay, I'm gonna start with A, B, C, and yeah, I have to have a plan. So the plan is the following: start with Python, start with artificial and neural network, because Python is before R and A is before everything else. Start to see and learn from there, and then everything else becomes easier. But don't approach it with a shield and you're trying to hide yourself, or like to hide from. It's not that. It's not really that hard. And if somebody who graduates with a very low GPA can do something with machine learning, I'm pretty sure that probably like 95. I'm not even good with probability, but like there's a very big likelihood that you'll be able to do the same thing, and even more, much more better for sure.
Yeah, absolutely agree. And there's so much information available. Your book was a great introduction to the entire landscape of machine learning in a sort of an engineering context. You've got so much stuff in there, and what's interesting is you have you have like, the core information in the book, and then you also have these footnotes that are kind of like your thought process or just your opinions on things. And at the beginning, when I was looking at it, I was like, this is strange. I haven't seen this before. But then as I was working my way through the book, I could start to understand your thought process and stuff. And I really liked that format, because you were just adding in like, well, I said this, but I also think this. And it's just interesting. It just adds a bit more nuance. So I really like that, the way that you did that. I haven't seen that often in books.
Thank you. And this really goes back to my self of like I really wrote this book for myself, because I was teaching myself, and because I had like all these things in the past, like I was thinking, if I write it this way, then I'm sure other students might have questions. So if I put in my thoughts, it might be a little bit easier to at least to grasp what I'm trying to do. But as you said, there's a lot of nuances there that you don't really have to go through them. But if you happen to have time, please send me your thoughts and ideas. I would love to always hear back on those, and maybe do something better next time. I
Yeah,
appreciate
no,
that.
it's because that's how I think when I'm reading a book. And then I'll be like, I'll think something, but then I'll see you're thinking stuff as well. So it's just, I don't know, it's a cool way of doing it. So there was some interesting, there's an interesting plot that you had in there, which showed the publication trends over the last few years, and how there's been like a marked increase in AI related publications in civil and environmental engineering. So you're in the research field. Like, where do you feel all of the effort is right now? And if I had $10 billion to put into research, Like, where do you think it should go? And what do you think is like sort of the next big phase in the AEC industry?
Oh, that's I would love to have 10 billion to do research. That'd be amazing. But uh, I think it's for the most part. I mean, I've been tracking the publication. For the most part, I think AI is still a little bit newish, so a lot of interest is there. Plus, it's very cheap, so you don't really have to have like an experiment or like to have a lot of money to do AI research. There is a lot of data online, so it makes it even much more easier. A lot of algorithms, as you said, are open access, makes it much more easier. Of course, whenever there is a lot of accessibility, you start to see stuff like, let's say, paper X, where I'm using algorithm A to predict compressive strength of concrete. Then paper Y, I'm using algorithm C to predict the compressive strength of concrete. I mean, there's going to be a lot of papers on the same topic, which makes it a little bit redundant because, for instance, we don't really have to have this many things to predict one property. It's always good to try, but it may not like worth publications. That's what I'm trying
Yeah,
to say.
yeah.
Now, where we would like to go is, at least in my view, uh, I really like the idea of having like a AI engineering co-pilot. Like for instance, let's say you're designing something, and like let's say your computer, you're designing something, and you have like this AI bubble or that pops up and say, oh wait, we could do this step, or like we could choose this section because we have, for instance, it would be like maybe less CO2 generation, like it could be like less on cost.
Hmm.
So I think if we can create something like this and like make it much more and make it open access to all engineers, that would make all of our life easy because I would like to see a lot of us use or create something that would make a lot of our lives a little bit more easier on the design process and analysis process. So that would be something very cool I would like to see.
Is this related to? I saw you posted something recently about Steel GPT. Is this what you're working on?
Well, still GPT would be something along those lines. I think, well, AISC, the American Institute of Steel Construction, was very, very kind to supporting this project. I know they took a big leap of faith on it, so I'm really trying to not be overly optimistic and over promise things. But I really think Steel GPT would be one of those things where everybody would be able to use AI for design analysis at a much easier rhythm with much more accurate ways and faster solutions. It would be like it should be a co-pilot. For instance, you're designing something, it would guide you through the process, try to give you advancements, advices. If you're stuck in a way or in a scenario, it would give you solutions, not just one solution, but like a series of solutions, where it would make your life a lot easier, and it would be much more eloquently designed. I really thank Steel GPT because my favorite, the thing I'm really tied to Steel GPT is I like the feedback process. So let's say when it gives you 4 or 5 options, and based on your experience, you're gonna have to choose one. And the more you do this, the more still GPT will understand, well, this is the engineering preference. So it will also learn from you. It's just like a one-way process. It's a
Mm,
two-way process between like machine and people.
interesting. I tried a sort of a similar experiment where I tried to train a model on the ACI concrete codes, and I ended up. It was complicated because there are many, as you know, there are many different formulas in there, and there are tables and plots and charts, and a lot of like visual complexity that make it difficult for a model to, it goes much far beyond just text. And so I started off trying to process all of this stuff and was getting mediocre results, and then burnt through all of my budget. I didn't have a. This was before the days of having a limit, or hadn't set a limit on it, and I wasn't thinking, and I burned through. I don't know how much it was. It was like $200 in a couple of hours, and then I was like, no, this is unsustainable. So I ceased research on that front until somebody gives me $10 billion. Um, but I think there's something there. I think that's kind of what you're doing with Steel GPT, like something similar. Uh, um, like, are you using the Steel codes to kind of feed that into the model?
Correct, correct. So if you think about, like, for instance, I always have the steel manual. If you think about the steel manual, as you can see, we have all those like very nice tables and stuff. Now, every point, a lot of people don't know, but every point is actually an observation. Like, for instance, somebody took this point and they tested the beam or column, and we actually have a measurement. So
Mm.
the more you have those measurements, it's like an experiment. So you have all these experiments, and this is useful information. And we could also use the data. For instance, we can also include some physics into the machine learning models. For instance, we say, okay, this is the data we have, this is the physical equation we have. Now between both of these, we have to build a model that can accommodate both data as well as the physics we know.
Mm.
And this is how we can improve. So in
Yeah,
a way, a lot of the misconception becomes this is just like data driven analysis, but it's really not just data driven analysis. There is a lot of things that we could do to make it like physics based analysis, physics informed analysis, causal analysis. There's a lot of things that we could do to make our models much more accurate. And at the end of the day, here's the bottom line. This is why, for instance, we update building codes every 5 years or every few years, because new information comes into place. Which means that, for instance, the building code we have 20 years ago doesn't we don't carry the same process or the same equations now because we have new data. So data is important and building codes are important, but AI or machine learning would make that transition. I feel, I hope, much more accurate, much more faster. And if we can do this, immediately we can lower cost, improve safety, improve durability, sustainability, reduce like carbon emissions. A lot of things will also come into play.
that's a really good point, and it's somewhat related to some of the physics-based AI modeling that like Altair and Ansys are doing. I haven't used any of those tools myself, but it is interesting how they can, rapidly generate prototypes that would take many hours to run those models. And I see like huge applications for that kind of stuff in,
Mm-hmm.
CFD work, or just trying to deal with like we do a lot of hydraulics here, and we spend a lot of time on um, fluid dynamics, and having something like that would be extremely helpful. So what you're saying is you can kind of bridge the gap between the data driven insights, but then actually also cross check it with real world physical equations, to give you that sort of engineering certainty, we'll say.
Correct, 100%, 100%.
Yeah,
Yeah, I mean,
that
if
is.
we do this, our life would be a little, like, imagine this, instead of, like, as you mentioned, like building a model that would take, I don't know, like 8 hours to run at minimum. If you use the AI approach with physics, it may like run in, I don't know, maybe like 10 minutes or 15 minutes. This means you have like 7 more hours to run several other projects, which mean like more quality of life, more well-being, more money for your company, and like it would make a lot of things also work at the same time. And once we start to do this, we will have enough time to work on like much more complex problems where we actually have to sit down and think. Maybe building codes don't have enough information on it. Maybe we don't have equations for. Then if we focus on the other ones, then we will also improve safety on other things. Like, for instance, I'm sure somebody out there, they have like this weird situation where they would have to design something, but like, let's say the guidelines in a standard or a building code is not complete, and they would have like to end up designing the thing like 4 times as big as it's supposed to be. Now, this is a lot of resources that you have to spend, and hopefully you won't have to do that anymore.
So I wanted
Mhm.
to ask one final question before
Go
we
ahead.
sign off, and it was, what do you see? So it's not like AI is obviously a fantastic tool, and we're going to be using it for, every sector of our lives moving forward, without a doubt. We already are in many ways. For engineering specifically, where do you see the biggest risks, the biggest hurdles, and I guess almost from like a policy standpoint, I feel like they're going to be slow to adopt things. Like where do you see the biggest risks?
Like, for instance, if we think about like software, let's say, not talk about, let's talk about like, if a software gives you a prediction, like let's say it gives you this kind of thing and you sign on it, is it the engineer's fault that they signed on this, or is it like the software's fault that they did some wrong math? I think a similar approach would have to be followed for machine learning. I think the biggest issue with machine learning is we don't really have like a big name company that would say this is like a machine learning software that everybody can use.
Yeah.
We do have those on other software, which makes it a little bit easier for liability stuff because they've been standardized in a way. But machine learning up to now is just open field for everybody to use. And once, let's say, a building code says we're going to use this software or like we recommend this, it becomes a little bit easier on the liability side, I believe.
That's yeah, you've raised a great point, because right now, no matter whatever you produce, however you produce it, in whatever way it's done, once you apply your stamp, like, you're responsible for this design. So whether, if that means you have to take apart the code base of SAP 2000 and understand how it, does this specific non-linear calculation, that's on you as the professional engineer. And I think it's going to be the same thing with using these AI tools where, in a courtroom, they will say, hey, you can use whatever you want. You can use a pen and paper for all I care. But if you're a professional engineer and you're going to stamp something, you need to validate it however you want. And I think that's probably the cleanest way to proceed, even with AI. And as you said, no company like OpenAI or Anthropic they're not going to hold up their hand and say, we will take legal responsibility for any bridges that may collapse.
No,
It's not going to
no
happen.
way. Absolutely, 100%. Yeah.
So Mohammed or Naser, thank you so much. We still only scratched the surface. There's so much stuff that I would love to talk to you about, to dig in. But I really just wanted this first discussion with you to give people an overview of the machine learning sector and how it fits into engineering. I'll share all of your material in the show notes, and hopefully that we can talk again about something. Maybe we'll get some feedback and get into something with a bit more specific. And so I guess before we go, for the Steel GPT thing that you are working on, do you have anything else that you can share about that in terms of timelines, or is this just sort of like you're quietly working on this, leave me alone, it's top secret?
No, it's really not top secret, but the project will start like at the end of August. So the first, I didn't start. It will start in like I think in 2-3 weeks from now, and I have like a 4 year duration to finish the project. So I'm pretty sure like along those 4 years, like probably every 6 months or so, we're gonna be like having like a LinkedIn post that here's what I have, guys. Maybe test this or like evaluate this, send me your feedback, because I know with AISC we're really trying to make this like as much open access as we would like to have, as many feedback on it as we would like. So I'm gonna be posting a lot on this process, but to this point, we didn't start yet, but I mean, we didn't like start coding the process. That we have like a very nice roadmap for it, but we haven't started coding it because the project should start like once the fall semester starts. Because this is when I can like pay my students to actually work on the project. I don't want to do it anytime before that. But I'm really hopeful it would be something great, and I'm like trying to focus as much as I can on this project.
Cool. Yeah, I'm excited to hear. I'm excited to hear the updates. Okay. Thank you very much, Naser. Thank you, everybody, for listening, and we'll see you guys in the next episode. Be good out there.